All right, so today we're going to be working 7, 8, 9, and 10 from the review homework. And you take a look at this and you got two students who are on a balcony 20.3 meters above the street, and one student throws a ball vertically downward at 14.6 meters per second, and then another student at the same instant throws a ball vertically upward at the same speed. This is not going to go well. We've got two students throwing things off a balcony. And so this person then throws that upwards, and it goes upwards, but then it misses the balcony coming down, and so then it also heads downward toward the ground. All right, and this one was thrown with it was thrown upwards with a positive 14.6 meters per second. This one was thrown downward at 14.6 meters per second, and so I'll just kind of label it right in here, negative 14.6 meters per second. All right, so great. So this one is thrown downwards, this one is thrown upwards. So they're thrown at the same speed, but this one is thrown downwards, and so we give it a negative sign, and this one's thrown upwards, and so we give it a positive sign. Now, the balcony itself is 20.3 meters tall. That means that delta y for either of these will equal negative 20.3 meters. And that's because the balls are going to finish 20.3 meters below where they started. And so it does not matter that this one goes upwards and then falls downwards and this one just goes straight downwards. In both cases, what we need to know is where did they start and where did they finish. And so they finished 20.3 meters below where they started, so delta y is negative for downwards, 20.3. All right, now also we know that these balls were thrown. They're only being influenced by gravity, and so their acceleration is the acceleration due to gravity, which is negative 9.81 meters per second squared. Remember, on your homework, this website uses 9.81, and it's downward. So if it doesn't tell you otherwise in the problem, the acceleration due to gravity should be considered 9.81 meters per second squared downward. All right, and so we've got that. And then question number 7 says, what is the magnitude of the velocity of the first ball just as it strikes the ground? Okay, so here we have the first ball. It's about to strike the ground, and we just want to know how fast it's going. So for this one, let's see, I'll just kind of work right here. Number 7, we're asked for VF equals question mark. Now I'm going to find the velocity, but then I will enter it as positive because they ask for the magnitude of the velocity. All right, let's see. Now I have its initial velocity. VI is negative 14.6 meters per second, and my delta y and my acceleration are given right over here. So I'll just say VF equals VI plus AT, and then my VF is going to be negative 14.6. Whoops, excuse me, that's what I'm looking for. And so let's leave that as a letter. VF equals, and VI is negative 14.6. Sorry about that, huh? Happens. A is 9.81. All right, and there we go. There we have that. So VF equals VI plus AT. And since that's a negative, I went ahead and put plus the negative and just went ahead and substituted it all at once. All right, and so at that point, then I'll swing that across and have a, let's see, whoop. Great. So we're going to scratch all that. My audience let me start with 2 unknowns. Who does that? Okay. Why did you all let me do that? So I'm going to get my big eraser out and just erase all that. That's right. Shout out to Christian right over there. Thank you, Christian. I really think we should just blame you personally for that. So since we don't have time, we will need to use our timeless formula. So VF squared equals VI squared plus 2A delta y. This should go much better. VF squared equals, and then our VI squared, of course, will be negative 14.6 squared plus 2 times negative 9.81 times negative 20.3, and that's a 0 if you look closely. All right, so then I will multiply that, and the negative times the negative will be a positive. Once again, that's why the signs really need to match, and I will add it to negative 14.6 squared. And then I'll have a large positive number. So I'm going to pause for a second and do that on my calculator. All right, so when I did the math, I came up with VF squared equals negative 14.6 squared plus 2 times negative 9.8 times negative 20.3, and all that ends up being 611.446. When I take the square root of both sides, I get VF equals 24.7274. At least that's what my calculator says. Now remember, you are a bright student, and so you know that this object is actually headed downwards, and so you need to choose the negative root. And so really your final velocity is negative 24.7274 meters per second. Here's the catch though. When you read the question, in this case, your homework wants you to enter the magnitude of the velocity. So you will just put in the positive value for this, because the magnitude is just the size. So you'll just enter the magnitude, and that will be your answer for number 7. So 24.7274 meters per second. All right, so that's number 7. Then you read number 8, and it says, what is the magnitude of the velocity of the second ball? Okay, and here's where we need to start thinking. Now, check this out. When this one, here's the second ball, gets thrown upwards at 14.6 meters per second, it goes upwards, and here at the peak, ask yourself, what's its velocity? And you remember that that's 0. Okay, and so the velocity at that point is 0 meters per second, because it's at the peak of its flight, and then it begins falling back down. It's accelerating under the influence of gravity. And at this point, I want you to think, how fast is it going? And remember, if it was going 14.6 here, then it will be going that same speed when it reaches that same spot on the way down, but of course downward. And so the velocity at this point will actually be negative 14.6 meters per second. Because it is that same velocity when it comes back to the same spot that I've denoted there with the green dotted line. Same spot, but it's the negative 14.6 instead of the positive. Oh, now wait, that's exactly the same as what this one was. So at this point, these two balls are both going to make identical trips downward for the rest of the time. They're not going to make the trip at the same time, because this one got started right away and this one made a little detour when it went up. But once it gets back to here, the end of its trip is identical to the trip of the first ball, which means that for number 8, its final velocity is also going to be negative 24.7274 meters per second. And I didn't actually have to do anything. Again, remember that you're going to take the absolute value of that. So I didn't actually have to do any more work to figure that out. You just had to do a little bit of thinking. All right, and then number 9 asks us, what is the time difference for these two? All right, well, since from this point, okay, so the first ball, it takes a certain amount of time for it to, it's thrown this fast and it goes this far, and so that takes a certain amount of time. Well, this ball, once it makes this little trip, from here it goes that fast and it goes that far, and remember those are the same. So this part of the trip is identical for them. And so the time difference is actually going to be this part of the trip that I've just circled in blue. And so that is going to be the part that we need to check for the first ball in order to know what the time difference is. The time for the first ball and the time for this part of the second ball's trip are the same. So the time difference is during this part of the trip for the first ball that I've circled in blue. All right? I'm going to take the Well, I'll leave the blue writing on there. So anyway, this is what I need to see. So now I'm going to be solving in blue. Notice that my initial velocity is still 14.6, but my final velocity now is negative 14.6. So VI equals 14.6 meters per second. VF equals negative 14.6 meters per second. My acceleration is still the same. Acceleration is negative 9.81 meters per second squared. And interestingly enough, since it finishes at the same height where it started, delta y is actually 0. And so delta y equals 0 meters. So at that point, you literally have everything except time, so you can choose any formula you want in order to find that. I like this one. I'm a fan. VF equals VI plus AT. VF is negative 14.6. VI is 14.6 minus 9.81 times t. All right, so I'll pause it and do the math. And so when I do the math, I swing 14.6 across and subtract that from both sides. I get negative 29.2 equals negative 9.81 t. Then I'll divide both sides by negative 9.81, and I'll end up with t equaling 2.97655 seconds. And that is, in fact, the time for my circled blue area for the first ball, and that is the time difference, since they both take the same amount of time to fall from here on, since they have identical velocities and cover the identical trip at the identical rate. All right, so the last part then is number 10. Give us just a little bit more space there. And number 10 asks, it says, how far apart are they? And mine says after 0.664 seconds after they're thrown. So what we need to do for number 10, and let's just switch to another color. So for number 10, we are going to find delta x for ball 1 and delta x for ball 2, and we're going to see how far apart they are, and then just at 0.664 seconds. So t equals 0.664 seconds. All the rest of my information remains the same. That is, VI for the first ball is still 14.6. VI for the first ball is negative 14.6. VF for the first ball is positive 14.6. And the acceleration is still that due to gravity. All right, so at this point, let's see, I'm going to choose delta y equals, because that's my displacement, VIT plus 1/2 AT squared. And I'll just find for ball 1, I'll put in the velocity of ball 1, which is negative 14.6, times t, which is going to be 0.664. And then I'm going to add, let's see, 1/2 times negative 9.81 times 0.664 squared. All right, so delta y equals VIT plus 1/2 AT squared. All right, let's pause and math. And so at this point, you see that negative y, or delta y for ball 1, VIT plus 1/2 AT squared. When I do that math, I get this number. When I do that math, I get this number. And when I combine those, I find that delta y for ball number 1 was negative 11.857 meters. So it has gone downwards 11.857 meters at this time. And so that's the key, is to be sure you're using this time. Now earlier I said that this was delta x. It's vertical. That's delta y. So I'm just going to change that real quickly. So delta y1 and delta y2. There we go. And so that's what we're doing. So now I need delta y2. Now remember, it's thrown upwards, so its velocity is going to be 14.6 for VI. Again, T is going to be 0.664 because that's the time that they gave us. So delta Y equals VIT plus 1/2 times, I need a little more space, A times T squared, 0.664 squared. All right, and then I'll do the math for that and see what I get, and then I'll just need to combine them in order to find the total distance apart. All right, and so at that point, again, when I multiplied these, I get the same number that I did earlier. Earlier it had a negative sign, now it has a positive sign. That's because of the different sign for my VI. And so I have this value, and then once again I'll be subtracting that. But this time I have a positive value, subtract that, and I see that delta Y2, that ball is actually headed upwards. This ball, negative and negative, it's headed downwards. And that makes sense. We threw this one downward, we threw this one upwards. And so now at this point, I just need to know how far apart they are. So the delta Y total, the total distance apart that they are, this one's gone downward almost 12 meters. This one's gone upward about 7.5 meters. So they'll be about 19.5 meters apart. And so you just need to add their absolute values. And when I do that, I'm going to get, let's see, doing the math real quickly, that one plus that one is 19.388 meters. And so that will be my final answer for number 10. And again, remember, it asked how far apart they are, and so I just need to add the absolute values of these because it's that far downward and that far upward. And so you can see if that one goes down that far and this one goes up that far, they will actually be 19-ish apart. All right, I hope that that was helpful, and I hope you have a good day.